in 1.2, we're just looking at given graphs and being able to know things about the graphs and everything. Okay, so a lot of this stuff I'm just is hopefully a review to you, and just kind of to look at. You want to know the terminology. So here's a graph. I just took this out of the book. I've given certain points on the graph. So if I ask for f of 8, what am I asking for?
Y.
Thank you. Okay, I'm asking for the y value when x is 8. Okay, that's it. Okay, so if x is 8, then you're looking at this point right here. Yeah, you're looking for the y value, so that would just be -2. Okay, same thing. On the next one, you're looking for the point when x is 0. Okay, you're looking at that point. So what's the answer? 3. Okay, and so forth. Okay, that's the terminology that you want to make sure you know. The next one, x is -1. You just look at the point, which I didn't put on the graph, I don't think. So you just have to kind of estimate this one. So it looks to me like that's a point -1, 2. So that's probably 2. That's just estimation. Okay, so that's asking for y values or function values. Okay, all right. The next thing that I want to look at is, and again, these are just questions to see how well you understand the graph, what it's saying for what values of x is f of x 0. So what does that mean? That means find on the graph every place where y is 0. Okay, so, and then just find those x values. So what you'd be looking at is there's a place where y is 0, here's a place where y is 0, and there's a place there. So what are the answers? X values, -3, 6, and 10. Okay, that's just the interpretation. A lot of times students get into the class and they don't remember what function notation is. So that's part of the purpose of this, is to make sure that you're solid with that. Okay. Okay, next question says, where is f of x less than 0? Okay, well, you got to write an interval on this. So what does that mean? If f of x is less than 0, what part of the graph would that be? That would be places like here, where you have negative y values, and where else? From there to there. Okay, so you're going to name that in an interval, and you're going to name that in an interval. Okay, now one thing you got to pay attention to is this thing says less than, which is going to mean our intervals are going to have parentheses on it. Okay, so we just need to name this interval and that interval left to right. So you got your interval notation that you want to know. So we would say, now on this one, let me ask this, because would I do a bracket for -6 or a parenthesis? What do you think? That stuff's picky. It'd be a bracket, right? Isn't the y value negative? Okay, so if the y value is negative, then you include that. So we have bracket -6. Okay, how about the -3? What do you think? Parenthesis or bracket? That's parenthesis, because its y value is not negative. Okay, remember what we're doing is, where are you strictly less than 0? The y values are strictly less than 0 on that interval. Then the next one goes like this. The 5, again, it has a y value of 0, so that doesn't count. So we'd have parentheses 5. Then you'd go to 10, this point here, and then that would be a parenthesis like that. Okay, so that's how you got to do that. The -6 is included because it has a negative y value. Does that make any sense? Okay, pay attention to stuff like that. Okay, if I ask for a domain, tell me what I'm asking for. What am I looking for? All the x values, right. So if you look at this particular function, it's always defined. There's no place it's undefined. So we're just going from -6 to 11. Okay, and you name that in an interval, and this would be included, okay, because you have solid dots on your endpoint. So what we'd say on this is we'd just say from -6 to 11 would be the domain. Okay, what am I asking for on range? Y values. Okay, so we're doing this way. So what's the lowest y value in my graph? -3, right? What's the highest y value? 4. So our range is going to go from -3 to 4. So range, you're looking at the range of y values. And that fits everything in there, so we would just say -3 to 4 like that. Okay? All right, everybody got this okay? This hopefully is background stuff that you just want to review. Okay? Now the next thing is the X-Intercepts. So can you tell me how many X-Intercepts are on this graph? Just how many? There's 3, okay? It crosses the x-axis 3 times, okay? And you just name those points. So the X-Intercepts would be, and we'll name these as points, -3, 0, and let's see, 6, 0, and 10, 0. All right, we got that. How many Y-intercepts does this graph have? Just 1, okay? What would be the deal if it had 2 Y-intercepts? Would it be a function if it had 2 Y-intercepts? No, because you'd have that vertical line test would fail. So typically if you have a function, you're only going to have one Y-intercept. So that Y-intercept is the point 0, 3 like that. Okay? So that's what we have there. All right, now the next question, let's see what this one's asking. This just says, how often does the line y equals -1 intersect the graph? Okay, what does the graph of y equals -1 look like anyway? Now that's this way, that's a horizontal line. So what I'm going to do on this is I'm just going to kind of go like this in my mind. That would be the line y equals -1. So how many times does that line cross the graph I gave you? Looks like 3 times. Okay, so it would be there, there, and there. So that looks like 3 times. Okay, a lot of this stuff is just, do you understand the language of what's going on? Okay, and let's see, next one, it says, what values of x does f of x equal -2? So what that means is y is -2. And if you look at the graph, you've got to find how many x values have a y value of -2. So how many points on this graph have a y value of -2? What do you see? There's 2. Good. Okay, so it would be this one, and it would be this one. Okay, they are the only 2 points that have -2. So that means the answer on this would just be x is -5, and x equals 8. Okay. And then the next one's the same thing. It says, for what values of x is f of x equals 10? Okay, now again, this is giving you the y value of 10. Okay, does this graph ever have a y value of 10? No, so there's none on that then. Okay, so your textbook has a few problems like this because it's basically just how well do you understand a graph and how well can you interpret it. Okay, that's the whole purpose of that. Okay, anybody have any questions about anything so far? Okay, all right, now we're going to kind of move on and start looking at some other functions, and that's mostly what we do in this section is graphs interpretations. Okay, so the domain, okay, somebody said a minute ago, what are you looking for in a domain? You're looking for all of the x values. Okay, the range, you're looking for all of the y values. Okay, now if you have an x-intercept goes like this. You have an x value and y is 0. So anytime you have an x-intercept, it's on the x-axis and that's why y is 0. If you have a y-intercept, it goes like this. X is 0 and then you have some y value. Okay, so in y-intercept you have x equals 0. Okay, all right. So we'll just kind of do, I'm going to do this one, and then I'll let you just kind of take a little time to do a couple so I can see if you know what's going on. Okay, this has 2 x-intercepts. Okay, so let's just name those. So the first x-intercept would be 1, 0, and 3, 0. Okay, it has 1 y-intercept, so there's your y-intercept, which looks like 0, 3. Okay. What does it look like the domain is? What do you think? All real numbers, right? It goes on forever in both directions, right? It doesn't come to an end, so you would just write that in an interval, -infinity to infinity, okay? Like that, if you want to write that in interval. How about the range from where to where for the y's? What's the lowest y? Negative 1. Okay, good. So we would say negative 1 with a bracket, and the reason you say bracket is because that's a definite point on the graph. Then you would say to infinity like that. So that's the idea. Okay? Everybody with me there? Okay? I have no idea what everybody's backgrounds are like in here, so I kind of, beginning the semester, got to find out a little bit here. Okay, so you guys go to the next page, and then I'll just give you all a little time to do these next three here and see if you're okay with the definitions and stuff on here. Yes?
Just a question about the notes. I'm a little unclear. Should we be printing our notes out, or are they going to get passed out in class?
Well, for this week, they're going to get passed out. Okay? And then starting next week, you'll have to print them out.
Gotcha.
Because they only give us a certain amount of things to print. And like I was saying, if anybody's got like a tablet or an iPad that you can write on, an Apple Pencil, then you can just create OneNote. And if you're not familiar with OneNote, it's pretty easy to learn. That's what I use. And then that way you can just write. I think, is anybody doing that? It looks like you're doing that. Is that working okay? Yeah, so you can just do that. I think I already got all the notes posted for this week anyway. So I've had more people doing it that way. And if you have the technology, the type of laptop. Okay, so let's see. The key thing is just that you're writing these correctly. So I'll see if you can kind of check and see if you're on the right track. So let's see. The first one, you had two X-intercepts. You have negative 1, 0. And if I ask for an X-intercept, I really want you to write a point instead of just saying negative 1 and 1. Write the points. And then how about the Y-intercept? Well, it doesn't have one. Okay, that never crosses the Y-axis, so you don't have one. The domain, there's really two parts of this. You're going from negative infinity until you get to negative 1, and then you would have a bracket. So if you didn't get these brackets and stuff right, make sure you correct that and pay attention to that. So it's forever to the left. Negative 1 is a definite point on the graph. Okay, then you use a union. Whoops. So on the union, just joins the next one. Then it would be from 1 and then forever to the right, so it'd go like that. So you have to have a bracket on 1 and negative 1, but you never have brackets on infinity. Okay. The range, what did you get on the range? All real numbers. Okay, so it goes everything, y can be anything. So you write that like that. Okay, so that's what you should get. If you didn't quite get the brackets and stuff right, make sure you pay attention to those things. Okay, those of you who have had trig before, this is actually a graph of a cosine. So it has two X-intercepts, and I've given you this one has a X value of negative pi over 2, 0, and the other X-intercept is pi over 2, 0 like that. Okay, the only Y-intercept on this is 0, 1, so we have that. Always name intercepts as points. Okay, what's the domain? Where to where? Negative pi to pi, brackets or parentheses on the endpoints? Brackets, because you are including those in the domain. Okay, you're telling me what x can be. X can definitely be pi and negative pi. Okay, what did you put for the range? Negative 1 to 1, okay, with brackets is what you should have got there then. Okay, so that's the idea. All right, everybody okay? Okay. All right, and the next one, let's see. This one had one Y-intercept, or I'm sorry, one X-intercept. That X-intercept is the point 1, 0. And then Y-intercepts, it doesn't have any because this is saying that the graph approaches the Y-axis but doesn't touch it. So it looks like you would have none there. And then domain, what did you put on your domain here? What to what?
0 to 3.
0 to 3. Do you have brackets or parentheses? On both. Okay, and you have to have it on both. So you have negative 3. This thing, no. That's not what you guys said. You said 0 to something, right? And then 3. Now, why do I put a parenthesis on the 3? Because there's a bubble. Okay, that means it's undefined there. So you're basically undefined at x equals 3. So that's why you got to have parentheses on both. Okay, the range is going to go from negative infinity until it gets to the y value of 2. And does that 2 have brackets or parentheses? Okay, parentheses because it's not included. Okay, those are the details sometimes students, if you're not paying attention to, on the brackets and parentheses. You want to know the meaning between including and not including when you're writing intervals. Okay, all right, so that's kind of the first thing in this section you want to be able to do is given a graph, answer questions about it. Okay, does anybody have any problem with what you just did? Okay, all right. So the other thing that we're going to look at is the idea of symmetry, because we're going to focus a little bit the first couple of weeks of the semester on graphing. That's what we're going to work heavy on this week is graphing functions. So a lot of times students usually don't have too much trouble looking at a graph and know how it's symmetrical, but we want to make sure we know the mathematics behind this. So there's a couple of things that I'd like you to write on these. So this is an example of a graph that's symmetrical about the x-axis, okay? What I'd like you to write on this is these 2 points, okay? So this point right here looks like it's the point 2, 1, and this point right here looks like it's the point 2, -1. So what this gives is it's really this. If you're symmetric about x, it means if you have the same x, this is a good thing to write down, same x value, then you're going to have an opposite y value. Okay, that's what it means to be symmetric about the x-axis, is every point on this graph, if it has the same x, it will have opposite y's. One of them above the x-axis, one below. Does that make sense? Okay, so that's what the definition is. For every xy, you also have an x negative y. Okay, so that's the meaning of that then. Okay, this is an example of a graph that's symmetrical about the y-axis. Okay, so this point here, I'm just estimating what that is. That looks like that's the point 3. Then I have no clue. Let's just call it 10. Okay, I can't see all those things. But this point over here would be the point -310 if I'm doing that correctly. So what this means is if you have an opposite x value, then you have the same y value. Okay, that's technically what we mean by being symmetrical about the y-axis, okay? So the x's are mirror images of each other, but the y's stay the same. Is that logical and sensible? Tell me. Okay, because I want you to know these definitions, not just be able to identify this. Okay, now the next one we have is symmetry about the origin. So this point, I'm just going to say it's 3, 1. This point over here looks like it's the point -3, -1. So the other type of symmetry is this, and it basically just says if you have an opposite x value, then you also have an opposite y value. Okay, and what origin symmetry is this? Just think of it this way. It just means if you took any point on this graph and folded it over y, then folded it over x, it would go there. So if you folded it over, it would go there, then if you folded it over x, it would go there. Does that make sense? Okay, so you want to make sure that you understand how these points work in the different types of symmetry then. Okay, all right, any questions about what I'm doing there? Okay, because usually the hardest part of this for students is to be able to test for symmetry, so I want to show you that. So this one, I want you guys to go ahead and just take these 4 problems and just tell me yes or no for each one. Number 1, tell me yes or no, is it symmetric about x, symmetric about y, symmetric about origin. So it's possible they can be symmetric about all. Okay, so go ahead and do that. Okay. Okay, so let's see what we concluded on this one. Okay, this one, symmetric about x, what'd you get? Should get no. Okay, symmetric about the y-axis, that's also a no. Okay, now how about origin? Is this symmetric about origin? Yeah, what you want to know on this, and I mean, if you picked a point on the graph, this would be the point pi over 2, 1, and then notice that you have negative pi over 2, -1. So the thing that you want to notice on this, on origin symmetry, it just means opposite x, opposite y on every single point on the graph. The otherwise just think, okay, if I fold over y, then fold over x, they would come together. You understand that okay? All right. So that would be a yes on that then. Okay. How about number 2? What'd you get for the circle? Yes, yes, yes. Okay. It's symmetric about everything. So it's symmetric about X, Y, and the origin. Okay. How about number 3? What is it symmetric about? Y-axis. Good. Okay. So if you take this point, again, symmetric about the y-axis just means that if you have a opposite x, you have the same y. All right, that's how that goes. And everything else is, okay, it's definitely not symmetric about x, and it's not symmetric about the origin, because if it was, this point would have to go to -1, -2. Okay, both of them have to be opposite. Okay, all right. And how about the last one, number 4? What'd you get? No, no, no. Okay, all right. It's not symmetric about anything then. Okay, students usually don't have too much trouble with this. Origin symmetry is the one that's a little bit harder to see, I think. But X and Y symmetry, usually students don't have any problem with that. Okay, all right. So let's go to this last page, and then I'll finish this up. And this is on this one we want to do just a little exercise on function, and again, just doing some things algebraically. Okay, so let's see. With this, you're given this function, and then the question is this point on the graph. So what would you do to tell if that 0.1, -2 is on the graph without a graphing calculator? Plug it in, exactly. Okay, so like this is x. That's f of x, okay, that's your y value like this. So you just plug everything in. So you would plug in the -2 in for f of x, then you would plug the 1 in for x like that and see if it works or not, okay? So you would have -2 equals 2 times 1 squared minus 1 minus 1. So if that checks out, then that means that's a solution of the equation. Therefore, it means it's a point on the graph then. So that would be this side, 2 times 1 minus 1 minus 1. So that looks like -2 there. And then 2 minus 2. So that looks like -2 is equal to 0. So that's not a point on the graph if I've done my arithmetic correctly. Okay, so that's the idea. That's what a graph is. It's a picture of the solutions of the equation, really. That's the idea. Okay. And the next one, let's see, x equals -2. You're going to find, this really should say what is, I think I meant to type out f of -2. Okay, how do you find f of -2? You just plug in -2 into the function, and then you evaluate it. Okay, so we'll take the function, and then everywhere I see an x, I just work out the arithmetic like that. Okay, so that's going to be, it looks like 2 times 4 minus 2 minus 1. So that's 8 minus 2 minus 1. So it looks like that would be 5. Okay, so what is the point then on the graph? Okay, if x is -2, then the y value we found to be 5, like that. So that's what that means. Okay. Next problem is the same thing, it's just a different number. So what we're looking at on this one, well, this time I'm looking for x. So what you do with this one is take the function I gave you, and what you want to do on this is just replace f of x with -1. So this will be a little algebra background here. So we're going to have -1, go ahead. Are you talking about part B?
Yeah, part B is using 2x squared minus x minus 1, putting -2 in +2.
Oh, I see what you're saying. Yeah, I needed to do minus -2, didn't I? Okay, yeah, let me correct that. Ah, somebody's paying attention. Good. Okay, let's try again. Sorry about that. So you're going to have 2 times -2 squared minus -2 minus 1. So it's minus -2. Okay. So what you'd have is you'd have 2 times 4, and then minus 2 would be +2 minus 1. So that looks like 8 plus 2 minus 1, so that's equal to 9. Okay? Okay, so we'd have 9, and then we'd have the point -2, 9 like that. Okay? Everybody see what I did? Okay, it's minus minus. Okay, I didn't do that part correct. Now on this next one, part C, just replace f of x with -1, and then leave this alone, and then we're going to solve this equation basically for x. Okay? So the way we do this is you got to solve this equation. So this would be something in your background. Whenever you solve, this is a quadratic equation, you've got to get one side equal to 0, and then we'd attempt to factor this. So what I'm going to do is add 1 to both sides. That'll give 0 equals 2x squared minus x. So that crosses out. Okay? So you got to have some factoring skill then to put this together. So let me ask this question. How do you factor this expression? Does it have a common factor that comes out? Yeah, it has an x. There's an x there, there's an x there. So you pull an x out, and then you have your one set of parentheses. Okay? So when you're solving a quadratic equation, typically you try to solve by factoring. So I pull the x out, then I'd have 2x minus 1. Okay, if you distribute that in your head, you can see that's right. So I have 2x squared minus x like that. Then what do I do to finish up from your background? What do I do to each factor? Set it to 0, right? Okay, so what I do is I just say take this factor and set that to 0, and that would give me an answer automatically. Then I take this other factor, 2x minus 1 equals 0, then I solve that equation. Okay, so that's pretty easy to do. You can move the 1, so you have 2x equals 1. Divide by 2, so you're going to get x equals a half. So there's two x values that cause y to be -1. So those would just be x is 0 and x is 1/2. Okay, that's a quadratic equation. You'll see things like that from time to time. You'll see some of that on your MyMathLab, that prereq assignment a little bit. So you want to know how to do that and do your factoring well. Okay, all right, let's see. Domain, we talked about this last time. So from your background, can you tell me what the graph of that function would look like without putting it in your calculator? What kind of function is that? Does anybody know? I know some of you know, I can tell. Okay, it's a parabola, right? Okay, it's a quadratic function, right? Now, what's the domain of a quadratic function if it's a parabola? It's everything, okay? Everything works, and the thing is, there's no number you could plug into x where you wouldn't get an answer. So this one we would just say is all real numbers, okay? And then the X-Intercepts, well, we haven't done that yet, actually. So we need to, when you do an X-Intercept, what you do is you set the function value equal to 0. Because what you're trying to do on X-Intercepts is you're trying to get a point x comma 0. So you got to solve another quadratic equation on this. So what I'm going to do is take the function I gave you, replace f of x with 0, and then we solve that. Now that, I'm pretty sure that factors, so you would want to go ahead and factor that to find what your X-intercepts are on this, okay? All right, so let's do the factoring on this. Okay, so I'd have just 2x and x, okay, to get your 2x squared, because you're kind of doing FOIL backwards on this. Okay, the last term would be 1 and 1. I see a lot of students sometimes have trouble factoring trinomials in this class when there's a number in front of x squared. So this is the way I show this, is if you FOILed this, that inner term is just 1x. This outer term is 2x, and if you look at the problem, we're trying to get a negative 1x out of that. That middle term is negative 1x. So that's the, kind of tells you how the signs go. So how do you make 1x and 2x out of the negative 1x? How do the signs go on those two things? Plus 1, minus 2, okay? So see, you can figure out those signs like that. You can do that in your head, but a lot of times students do much better if they just write it down like that. Then it's pretty easy to figure out how the signs go. So that's your factoring. And then what we're going to have is, once you do that, you want to just take each factor. There's two factors. And you want to set each factor equal to 0. And you can a lot of times do this in your head. So we do 2x plus 1 is 0. Then we do x minus 1 is 0. Solve those two equations, and then you've got your two x-intercepts. Okay, so this one is 2x is equal to -1. Divide both sides by 2. So that's x equals -1/2. Okay, same thing over here. Just move the 1 to that side. So that's your other x-intercept like that. So typically I want you to write your x-intercepts as points. So you'd have -1/2, 0. Then you would have 1, 0 like that. So quadratic equation. All right, everybody remember that okay? Okay, if not, got to review it because you'll see that throughout the semester. Okay, and the last thing I want to do is when you do a y-intercept, the structure of a y-intercept looks like this. It's 0, something. So what you do is you just let x equals 0, so you just plug that into your function. So we're going to do f of 0, which would be 2 times 0 squared minus 0 minus 1, like that. Okay, work out the details. 0 minus 0 minus 1, that would be -1 like that. Okay, now a problem like this, of course, you could graph the function on your graphing calculator, and it would be pretty easy to tell that you're right on that then. Okay? All right, how do you feel about this section? Does it feel like it's in your background pretty good? Okay, that's different for everybody. I can tell some of you got it down and are bored, and some of you may need to come by and see me a little bit. Okay? So I'm going to pause there. We're going to go ahead and do a break right now, so let's come back at 9 o'clock. Come up if you have any questions on anything. And you probably want to go ahead while we're on break. And if you'll just come up here and pick up one of these, we're going to do this section second half of class. So just come up and pick one of those up, and then we can take a break.